the next thing that we have here is called Scribble and the improper loop, where Scribble is a document-oriented dialect of Racket, which is a Lisp-like programming language. So it's just another document language, and it has an interesting behavior, unexpected behavior, where if we are trying to flat map a list, it doesn't really create the result that we would expect, like naively. We have to know the semantics of this language to actually understand what's going on and why it's not really working as we would think. And in the case of the system I'm developing here, this is not a problem. We are just using JavaScript, and the semantics of JavaScript are not really surprising here, so we can simply use flatmap to, let's say, expand more than one element into the document tree. So because the problem here is that we have a list of lists and we want to output it as an HTML bulleted list, which is flat. Like, for example, here we have 2 bullet points, each of which just displays the both of the items from the nested list, and we want to make this flat, as in just 4 bullets, A, B, C, D. And if we do this in Scribble, we would naively rewrite this like this, but the result we get is, instead of A, B, C, D, we get B, D, because only the last element of each of the nested lists is actually preserved. And here we have the same situation. So we have a list of lists. So we have 2 nested lists, A, B, and C, D. And to generate the expected output, we just map them also to each of these elements. We map to 2 li elements, and we use flatmap to just flatten it into the output. And the result is shown here. We can actually see the HTML output as well, which is here, A, B, C, D. So that's how this works. And the rest of the examples I show here are also from this paper, and they are much less interesting than the previous 3 examples we discussed. So I'm just quickly gonna go over them. So the first just shows how we can create a simple list of one item which contains the hello and then something that's taken from a variable, and it's written with a bold font, basically, emphasized. So that's how we would write this here, and this is how it looks in TypeScript. So yeah, and the output is unsurprisingly hello world. And if we change this to something else, for example universe, we will get this output. So the next thing is I guess just this is supposed to show that we can compute things, like splice the results of some computation. We have created a list in JavaScript, and we go over this list, map it to items, and each of these items has a spliced in values. So these values are going to be spliced in here, and then we show that we can perform addition on this. So the result list is basically here, So we don't have to manually compute these things. We just let the JavaScript compute it for us. Okay. And the next thing here is just shows how we can define references, basically. So we can just refer to something, which in this case is a link, and then we can define the target of this link basically afterwards. And the system is written in such a way that it will connect this correctly, because we just basically do 2 passes over this document here. Okay, so that is that, and the result we can see here. And we can compare this to Markdown here. Here's the Markdown version. So this says hello and then world in square brackets, which signifies that this is a link, but without saying where it goes to. And then on the bottom we can say that we can define the reference. And here in my system we just use this sort of syntax. It's very similar, but we have to mark it as a link, so it's less ambiguous. I mean, I try to make everything be easy to parse, so, and this really actually creates a lot of ambiguity in the Markdown, so we don't want that. And then we just use a def block. We could actually put more things in here and define multiple references. So it could be some other link, whatever, and we could do this. And if we render that, the result is basically this. Oh, you can see that these 2 links are the same. Alright, so that is that. And then the next thing that we have is, well, it's a very basic example. It just shows how you can create a paragraph with the emphasized word, but without using a syntax sugar, because with syntax sugar the same thing could be written as this, basically. Yeah, so the good thing about this format that I have created here is that you can opt out of the syntax sugar and just use like HTML like syntax to directly specify the tags and everything. But you don't have to write HTML and be verbose, because this essentially compiles down to HTML with a much leaner syntax, much less noisy syntax. Okay, so that is that. And I suppose the last example here is just going over a list of items, list of strings, and we just display them. I mean, that's also very similar to the previous examples, but in the context of these papers, these examples make a little more sense, because they describe various features of these document languages, and use these examples to analyze these features. But I mean, we can compare, I suppose, the same thing, how it looks in JavaScript, JSX, and Scala too. It happens to be the exact same code in both languages, and also in, I suppose, Visual Basic.NET. So this is how it would look in those 2 languages, and in our case it looks like this. And also we could opt out of the syntax sugar with this sort of syntax, which is closer to actually those 2 examples. where we explicitly specify the tags to be used. So we can see that we specify a paragraph, which is today I'm going shopping for, and then an unordered list, which is created by iterating over this list of items and turning them into, wrapping them, each of these strings into a paragraph and then into a list item. And this is effectively the same as this. And as we can see in the output, yep, and that is indeed how it looks. Yeah, and basically that's it. And we have tested everything here, so that's great. Also, I guess I can mention that I've implemented source code highlighting into the language as well, so it can, for example, highlight this block of code. Yes, and we have blocks of code very similar to Markdown, and we can use the backticks to make sure that whatever is in the code block doesn't conflict with the rest of this of the source. So that is pretty useful if we want to embed different languages into our documents. Okay, so that will be that. Thanks for watching and see you later.